All right, everyone. So welcome back. I hope you guys are off to a good start to your weekend here. Maybe some of you are watching this on a Thursday or Friday. Maybe you're just about to start your weekend. So today we're going to learn about our last transformation. We're going to learn about how to stretch and compress our graph here. Okay. So the first one that we're going to talk about is vertical stretch or maybe compressing. Okay, so we're going to talk about vertical first. Now, before we talk about what it's going to do algebraically, I want to just try to help you visualize what it's going to do to my graph. Okay, so the best way to do this is put down your pencil for a second. I need you to pretend that you're going to grab this graph. Okay, you're going to grab it at the bottom, you're going to grab it at the top, and we're going to vertically stretch it. So I want you to picture that you just grabbed a big marshmallow and you're going to stretch that marshmallow out. Okay, so that was a vertical stretch. I grabbed it, I stretched it vertically. Okay, now I want you to imagine grabbing that marshmallow on the top and the bottom and compressing it. And you're smashing that marshmallow. Okay, so a vertical stretch, we're stretching it out vertically, and a vertical compression, we're compressing it vertically. Okay, notice that I'm not doing anything in or out. It's just smashing it vertically or stretching it vertically. So that's what we're trying to do to our graphs here. Okay, so how are we going to do that? Well, instead of just telling you all the rules, let's see if we can kind of figure some of them out. So this graph here, this is F. He's very happy to meet you. So here's F. He's pleased to meet you. So we're going to stretch and compress F, but instead of just kind of telling you what's going to happen, let's see if we can figure it out. So I'm going to make two new functions. I'm going to make G and I'm going to make H. Okay, so I'm going to have G of X be equal to 2 times F of X. Okay, so that's G of X. And then H of X is going to be equal to 1/2 times F of X. Okay, so let's go ahead and make a table and see if we can figure out what's going to happen here. So F of X, so I have the points -3, -2, -1, 0, 1, 2, 3. That might be overkill a little bit, but that's okay. So 0, 2, -1, 0, 0, -2, 1, 0, 2, 3, and 3, 0. So take a minute, go ahead and pause if you need to, go ahead and make the table. Okay, so G of X. So G of X is 2 times the outputs of F of X. So to make my G of X table, I didn't say anything about changing the inputs. So the inputs stay the same, -3, -2, -1, 0, 1, 2, 3. But all the outputs, I'm going to take F of X, which are these values, these outputs, and I'm just going to double them. All right, I'm pretty good at multiplying by 2. So 0, 4, 0, -4, 0, 6, 0. All right, and then while we're here, let's go ahead and make our table for H of X. So H of X says take your outputs of F of X and multiply them by half. Divide them by 2. Okay, I'm pretty good at that. So again, it didn't say anything about changing the inputs, so I'm just going to leave the inputs -3, -2, -1, 0, 1, 2, 3. All right, so I'm just going to take all of my F outputs and cut them in half. So 0, 1, 0, -1, 0, 3/2, 1 1/2, 0. All right, so now I have my tables. So let's go ahead and graph these. So I'm going to graph G of X. Let's do that in blue. So I'm just going to plot all my new points. So -3, 0, -2, 4, -1, 0, 0, -4, 1, 0, 2, 6, and 3, 0. Okay, see if I can connect my dots. Oh, I forgot. Oh, no, I'm good. All right, here we go. Hey, not bad, Mr. Craig. Okay, so there, this blue graph, let's go ahead and, this is G. Okay, so there's G, and then while we're here, let's go ahead and make H. I'll go ahead and do H in red. So negative 3, 0, negative 2, 1, negative 1, 0, 0, negative 1, 1, 0, 2, comma 1.5, about there, 0. And there we go. Okay, so this red graph, this is H. Okay, so we have the black graph is F, the blue graph is G, and the red graph is H. All right, so here's the $1 million question: is what the heck's going on here? Okay, can you find out which one was stretched and which one was compressed? Okay, so remember, we said a vertical stretch is when we take the F graph, the black one, and we go, and we stretch out that marshmallow. So which one looks like we stretched out the marshmallow? Well, G, right? G looks like we stretched out the marshmallow. So G of X is our vertical stretch. Okay, and then what about H of X? Well, H of X looks like we grabbed the F graph and we smashed it. We smashed the marshmallow. And so H of X is what we call a vertical compression. Okay, and so we'll summarize all this later, but what happened here? Well, anytime we take a number that's bigger than 1 and we multiply it to our function on the outside of the parentheses, that's going to be a vertical stretch. And anytime we take a number that's in between 0 and 1, so some sort of fraction like this, and we multiply it by the outputs, we're going to get a vertical compression. So that's what happens here with our graphs, and that'll be the same with all your parent functions. All right, so I paused the video. I erased my G and H tables. I left my F table, and I came back to my original graph here. So if you need to take a second, and I would go ahead and redraw this if you don't mind in your notes. That's just me. You do whatever you want. So now we're going to talk about horizontal stretching and compressing. Okay, so let's see if we can visualize it first. So now, instead of grabbing your marshmallow at the top and the bottom and compressing or stretching, now we're going to grab our marshmallow on the sides. Okay, so a stretch would be, we're stretching out our marshmallow this way. A compression would be smashing the marshmallow that way. Okay, so we're going to try to smash this graph and stretch this graph. Okay, so let's see if we can kind of do the same thing we did before. Let's go ahead and create some functions, plot some points, and try to hypothesize what's going on here. So let's start by naming our function. So let's say G of X is F. Now remember, horizontal changes, it's impacting your input value. So a horizontal stretch or compression is going to be when we're multiplying right next to the input. So instead of changing the output values, now we're going to be directly impacting the input values. Okay, so then let's call H of X F of 1/2 X. Okay, so let's analyze what this is saying a little bit closer. Okay, because it gets horizontal is a little bit goofy. So what does this mean? This means that G is equal to F, but not all the time. Only when the inputs of F are twice as big as the inputs of G. So if F's inputs are twice as big as G's, another way of saying that is that G's inputs are half as big as F's. So what is that going to look like on my table? G's inputs are half as big as F's. So I have to divide all of these inputs by 2. Okay, now what does it say about the outputs? Well, nothing. It doesn't say anything about the outputs. So the outputs stay the same, but F's inputs are twice as big as G's. So my outputs, I just keep those the way they were. Okay, now let's use that same logic with H. So H is the same as F, but not all the time, only when F's inputs are half as big as H's. So what does that mean about h's? That means the inputs of h are twice as big as the inputs of f. So to make the table for h, I'm going to take all these inputs and I'm going to double them. And keep the outputs exactly the same. Okay, so that's how we make our table. So I'm going to go ahead and pause while I plot these points. Okay, so what happened? This might be a little bit counterintuitive to what we thought. When I took my F graph and I smashed it, I compressed it, I got G. So G is a horizontal compression. And when I took the F graph, the black one, and I stretched it, I got H. So H is a horizontal stretch. Okay, so let me erase my board and then we'll come back and summarize. Okay, so here's your summary for the day. So if I have a vertical stretch or compression, it's going to look like having a constant outside the function. When A is bigger than 1, it's a vertical stretch. When A is between 0 and 1, like a fraction, we have a vertical compression. Smash the marshmallow. If I have a horizontal change, it's going to be when I'm multiplying right next to the input value. If B is greater than 1, that's a horizontal compression. And if B is in between 0 and 1, that's a horizontal stretch. Okay? Notice horizontal and vertical, they're different. We said horizontal is always weird, and that's true here. If B is greater than 1, that's horizontal compression. Where if A is greater than 1, that's a vertical stretch.